Then, how to find a good model that has a small test error? Before going to the details, I want to define two different categories of parameters. Let's go back to the polynomial fitting example. In the polynomial fitting example, we can define many different polynomials. I want to use black. So degree 1 polynomial. So this is alpha 0 plus alpha 1x. Degree 2 polynomial. And so on. So here, alpha 0 to alpha m for a given polynomial function are model parameters. And model parameters are run from training data. Define loss function and look at the training data point and control the parameters so that your loss value can be minimized. Here, the m value define your function, shape, or structure. And this m value is a hyperparameter. This value define your model before looking at the training data point. It's totally independent to your training data point. And essentially finding a good model means finding a good hyperparameter that can have very nice test error. Okay. Then how to optimize hyperparameters so that the test error is minimized? We can use cross-validation strategy. In general, when you do some machine learning task, you have to collect data, of course. So this is the entire data, and each columns present one single data point. In general, we do not use the entire data point for training your model parameters. Instead, we split the entire data set into 3 different parts, especially nowadays. The first part is called training data, which is utilized for training your model parameter to minimize your training error. After that, you can have very optimized parameters for a given model. And this part is called validation set or depth set, which is for optimizing your hyperparameter. You can test many different models with different hyperparameter value, and then you can compare them using these data points. You can check what is validation error for each model, and then you can pick the best one having the lowest validation error. This part is test dataset, which is for testing your trained hyperparameter and model parameters. Essentially, This is your training process. You can set your hyperparameter m is equal to 1 and then you train your model, the first degree polynomial, and fit your data point and check the performance of the degree 1 polynomial using validation data point and compute the validation error. Let's say the validation error is equal to 2. Change your hyperparameter m equal to 2 and again train your model using training data and then check the performance using validation. Let's say this is 1.5. When m is equal to 3, do the same thing, check the validation error, set m equal to 4 and check the validation error. Let's say this is 2, this is 3. And from the validation error, you can find the best parameter, hyperparameter m, which minimized validation error. So in that case, the optimal hyperparameter m is equal to 3. That's it. Then you have very nice model from the validation error.